Next question, ninth number, x raised to sin x into sin raised to cos x. You must have now realized both are variable raised to variable form. So one way of doing, you express both of these in e raised to form, or you can take u and v. I'll just show you one step. Let me call this as y here. So y equals to e raised to log of given expression, that is x raised to sin x, and that sin x will come in product, that I'll show in the next step. E raised to log of sin x raised to cos x. Next step, this will be in the product, this will be in the product. So y equals to e raised to sin x into log x plus e raised to cos x into log of sin x. Now you just continue this by chain rule. This is like e raised to x, this is like e raised to x, and then as usual. Or this is just to remind you, you can do whichever way you like. Let's take y equals to u plus v. Call this as 1. Where what is u here? That is first function, x raised to sin x. And now you apply log on both the sides. So log u equals to log of x raised to sin x. Therefore log u equals to sin x, this will come in product, sin x into log x. And then you differentiate it. Find du by dx and go for v. What is v? That is sin x raised to cos x. Apply log on both the sides. So log v equals to log of sin x the whole raised to cos x, and cos x will come in product. Now differentiate it. So I'll get the dv by dx here. You'll get the du by dx here. And then you find here dy by dx equals to du by dx plus dv by dx. And you put here. This is just to remind you, this is one way, this is another way. Both methods are absolutely valid, remember, in the exam. You can write here reason. Which reason you have used? X equals to e raised to log x to the base e, remember. Both methods are valid in the exam. Whichever you feel easier can be used in the exam, remember. Do either way. This is just to remind you, remember. Question number 10 and 11, I leave it for you. Just try question number 10 and 11. After doing so many questions, I'm sure you can do this too. Now next, from question 12 to 15, you are asked to find dy by dx. This is a question from 12 to 15. So I'll go to question number 12. Question number 12. What's question number 12? X raised to y. You must have realized variable raised to variable form. Y raised to x, variable raised to variable, equals to 1. This is implicit function, remember, but variable raised to variable. So you need to use log function. Can I apply log directly? If I write like this, log of x raised to y plus y raised to x equals to log 1. And then if I write log of x raised to y plus log of y raised to x, you know log 1 is 0. This procedure is wrong, remember. This should not be used. If you have plus, you cannot apply the log. So this should not be done. This is wrong, remember. So what we'll do, you have two ways. You can call this as UV, or directly you can by E technique. So I'm using that E concept. Therefore, I'll just come to this. E raised to log of given expression. plus e raised to log of given expression equals to 1. That's a constant. Which property I've used? You can write here. I've used this. In the exam also you can write. You must write in fact. X equals to e raised to log x. That is what I have used here. Now next step. This is in the product. This is in the product. So e raised to y into log x plus e raised to x into log y equals to 1. This is just simplification. This was not the differentiation. Differentiation will be now, remember. Now we'll have a differentiation step. So differentiating with respect to x. Okay. What is derivative of e raised to x? E raised to x into d by dx of y into log x, chain rule, plus differentiation of e raised to x into d by dx of x into log y, and differentiation of any constant, you know it is 0. Okay. Now as we did, from where we have this? It is from this, that is from this, and that is from this. So I'll just replace this by x raised to y. Here, product rule. Y as it is. What's the derivative of log x? 1 upon x. Plus log x as it is. What's the derivative of y with respect to x? dy by dx. Implicit function. Plus, now come to this. From where we have this? From this, that is this. So this is y raised to x into, here product rule, x as it is. What's the derivative of log y? 1 upon y into dy by dx. Plus, now log y as it is. What's the derivative of x with respect to x? That is 1. Equals to 0 as it is. Okay. So differentiation is over now. We need to just simplify. How do we simplify? We just open all brackets. We get all the terms having dy by dx one side, remaining terms on the other side. So I'm just simplifying. This is not differentiation. This is simple algebra, remember. If I open the bracket, y into here upon x, so 1 less power, x raised to y minus 1 plus here x raised to y into log x into dy by dx. Y as it is, here x raised to y upon x, so here total power is y minus 1. X raised to y log x as it is dy by dx plus, come to this, here x as it is, here y raised to x upon y, so y raised to x minus 1 into dy by dx plus here y raised to x into log y equals to 0 here. Okay, now what we do, we collect all the terms with dy by dx in one bracket. Take this much common here. So I'm taking dy by dx common. So what will get inside the bracket? X raised to y into log x plus x into y raised to x minus 1 equals to, this term and this term are free from dy by dx. So I'll take these two terms on the other side, this term and this term. So minus y into x raised to y minus 1 minus y raised to x into log y. Fine. Now next step, this will be just in the denominator. That's what all in all about dy by dx. So here finally dy by dx equals to minus y into x raised to y minus 1 plus y raised to x into log y upon x raised to y into log x plus x into y raised to x minus 1. This is your final dy by dx. So here next 30 number, y raised to x equals to x raised to y. Now variable raised to form, variable raised to variable form. So we apply, you don't have a plus sign, so you can apply directly log on both the sides, applying log. You can use e raised to concept also, remember. Log of y raised to x equals to log of x raised to y. So x into log y, this will be in the product, equals to y into log x. Now this is implicit function, so you differentiate it with respect to x and get the dy by dx. So that you can do now. 14 number, more or less same question. Cos x raised to y. This is equation about mixed variable, remember. If you recall, this is called an implicit function. Implicit function, if you remember, as I mentioned earlier. But this is variable raised to variable form, remember. So we need to use either e or applying log on both the sides. So I'll apply log, that's easier. So log of cos x the whole raised to y equals to log of cos y the whole raised to x. Then both will be in the product. Y into log of cos x equals to x into log of cos y. I hope this is clear to you now. This is implicit function. Up to this we have no differentiation, just applied log, taken the product. Now differentiating with respect to x. I'll just show you one step. On both the sides, LHS, RHS, product rule. Y as it is. What's the derivative of this? 1 upon cos into derivative of cos, which is minus sign. 1 upon cos, derivative of cos is minus sign, plus this one as it is, log of cos x as it is, into differentiation of this dy by dx equals to here x as it is, differentiation of this chain rule. Imagine this as x, so 1 upon cos y. Now again, when you differentiate cos y, you need to imagine y is x. What's the derivative of cos y? Minus sin y into differentiation of y with respect to x. That's a dy by dx. Now plus log of cos y as it is into differentiation of x, which is 1. So I did differentiation for you. Now this term and this term are having dy by dx. You take these two terms on one side, remaining terms on the other side, and get the dy by dx. Right? That much you can do. I leave it for you, remember. The next question, question number 15 here. This is simple product and this is exponential, so you can do very much without log function, but this exercise based on logarithmic, so I'll apply log on both the sides. Applying log. Without this also you can do, remember. If it is asked in the exam, you can do without log as well. So log of x into y equals to log of e raised to x minus y. Now this is a product of two variables, so you can write into addition log x plus log y into becomes addition. Here if you have by chance plus, you cannot apply log, remember. Equals to, now what happens, this will come in product x minus y, and then what you will get here, log e, and nothing is given means base is e, so this is 1. This is like e to the base e, so this is 1 and this will come in product. Now this is very simple equation, so you just differentiate it with respect to x. Differentiation is now just 2 lines. How do we do? 1 upon x, here you know 1 upon y into dy by dx, chain rule. Derivative of x1, you know here dy by dx. Then you collect this one in one bracket and just get the dy by dx. So this is your answer. Not a big task for you now after doing so many questions. Okay. Next, question number 16. You have fx equals to 1 plus x, you must have realized, into 1 plus x squared into here 1 plus x raised to 4 into 1 plus x raised to 8. Now here you are asked to find f dash x first derivative, but before you do that, what you need to do, it's like question number 5. This is just similar to question number 5. What we do, we just apply log on both the sides. Product, you can use the product rule, but it becomes a little bit tedious. So before I differentiate it, I'll apply log on both the sides. So log of fx equals to, everywhere this product becomes addition. Log of 1 plus x plus log of 1 plus x square plus log of 1 plus x raised to 4 plus log of 1 plus x raised to 8. And now differentiate it. You can do it differentiating with respect to x. What is derivative of log of something? You imagine this as x. So 1 upon fx into derivative of fx with respect to x. How do we write f dash x? I repeat this. What's the derivative of log of something? It is 1 upon something into derivative of that fx. How do we write f dash x? Equals to, here use everywhere chain rule. Like you imagine this as x. So 1 upon 1 plus x into derivative of 1 plus 0, which is 1. Plus, you imagine this as x. This is 1 upon 1 plus x squared into, this is 0 and this is 2x. Plus, what about next? 1 upon 1 plus x raised to 4 into 4x cubed. 0 and this. Plus, what about this? 1 upon 1 plus x raised to 8 into 8 into x raised to 7. Then take fx over here and finally you get the f dash 1. You take fx over here. So if I write next step for you, so f dash x equals to fx into 1 upon 1 plus x plus 2x upon 1 plus x square plus 4x cube upon 1 plus x raised to 4 plus 8x raised to 7 upon 1 plus x raised to 8. This is what f dash x, which is this one. You can put the value of fx here. So therefore f dash x equals to, what was fx? That is that expression 1 plus x into this. Inside the bracket you can just copy this here. So this is your answer. This is your answer, remember. This is your answer. And finally f dash 1. That is, in the above expression, just to put x equals to 1. So we'll get the f dash x. And here f dash 1. Okay. Now next question is here. Question number 17. You are given one function here, let me call that as fx for example. That's a product of these two, x squared minus 5x plus 8 into x cubed plus 7x plus 9. Now here you are asked to find derivative in three different ways. First by product rule. So I'll be doing by product rule. You can do each of these three ways very easily. So what is f dash x? That is, you keep 1 as it is, x squared minus 5x plus 8 as it is. Differentiate this. That is 3x squared plus 7. This is 0. Plus, now this is as it is, x cubed plus 7x plus 9. Differentiation of this, which is 2x minus 5. 2x minus 5. And you need to simplify, remember, open all this bracket and simplify. This is f dash x. What is another way? By expanding. So there you expand first. So like this into this, that is x raised to 5. Then this into this, that is 7 in x cube plus 9x square. This into this, which is minus 5x cube. No, minus 5x raised to 4. Then minus 7 5s are 35x squared minus 45x. Then plus 8x cube plus 56x plus 72. First you just simplify and then differentiate it, because this become now polynomial, and find f dash x. That is the second way. You just simplify this. That's your second way. First way is what I did. Keep 1 as it is, derivative of this, plus second one as it is, derivative of this. This is simply product rule. You need to simplify. That I leave it for you. Second way is, first you open the bracket, you simplify and then you differentiate. Now what is the third way? That is, use log function. So third part is using logarithmic function. Use log function. So what we do? We apply log on both the sides. Here we apply log on both the sides. So log of fx equals to log of x squared minus 5x plus 8 into x cubed plus 7x plus 9. So this is as it is here, log of fx as it is. What happens here? Into becomes addition. So log of x squared minus 5x plus 8 plus log of x cubed plus 7x plus 9. And now we differentiate it. Differentiating with respect to x. Just into becomes addition. So what's the derivative of this? 1 upon fx into, by chain rule, derivative of fx, which is f dash x equals to, here use chain rule. So 1 upon x squared minus 5x plus 8 into derivative of this, plus this is 1 upon your x cubed plus 7x plus 9 into, by differentiation of this, chain rule, remember. And then finally f dash x equals to, this f will go this side, here fx, into, you have this upon this plus this upon this, and you simplify finally this. So you will get the required f dash x. In all the three cases, remember, final simplification remains same. This is just for your information. In same way, you can try question number 18, same way. There you are asked 1 by product rule. There one you do by product rule, and the second one you are asked by logarithmic. Use log and do it. I'm sure you can do it now after doing so many questions.